To stay updated, subscribe to TJ Academy.
Bismillahirrahmanirrahim. In this video, we are going to discuss error correction model. Error correction model is a part of Engle, Granger, two-step procedure. To understand the error correction model, we have to learn some terminologies. So for this, here, what is long run in econometrics? It implies that variables have converged upon some long-term values and are no longer changing. What does it mean? It means when model achieved a long-run equilibrium, so the value of variable would be the same in previous period and in current period, like this: yt is equal to yt minus 1 and yt is equal to yt minus 2. Same is for x. So if the all values are same, values of previous period, values of current period, value of future period, so it means the difference between these two values, if these both values are same, the difference would be 0. If both values are same, the difference would be 0 for x and y both. So hence all the difference term will be 0, like this: delta y is equal to change in y is equal to change in x is equal to 0. So this is the long run condition. This shows, these condition shows the long run equilibrium. So here the long run equation, when we run our regression model with the level data, so it means we are performing the we're running the long run equation, and when we take its change, means change independent variable with the change of independent variable, so it means we are trying to find the marginal effect. So this would be the short run equation or short run model. Here in above equation, beta shows the long run coefficient, and here the beta shows the short run coefficients, because the equation is for short run. Now, what does error correction model do? Error correction model do two things. First, it helps to find the short run relationship, whether variables have a significant relationship in short run or not. On the other hand, long run adjustment, what does it mean? Long run adjustment means whether model is capable to adjust towards long run equilibrium after facing some shock or not. So as we have discussed, the error correction model is a part of Engle-Granger two-step procedure. So here is the procedure, Engle-Granger two-step procedure. This is the first step. We have discussed in our previous video, Engle-Granger cointegration. The all step has been done there, but here for error correction model we have to repeat it. The assumption of Engle-Granger two-step procedure is all variables are stationary at first difference, or I1. Then we should start the procedure, the step 1. First we have to run our regression model like this. After running the regression model, we have to estimate our error or residual, this ET, and this is also called error correction term. Why it is called error correction term, we will discuss it later. First step, run regression model. Second, to find the residual or error correction term. Third, apply the unit root test on residual. If all variables are I1, as we have discussed, this is the basic assumption. if all variables are I1 means stationary at first difference, and error is I0 means stationary at level, it means cointegration or long run relationship exists. If this is the case, the long run relationship exists or cointegration exists, so we can move towards the step 2, otherwise we cannot proceed. So let's assume here we have a cointegration or cointegrating relationship. Now what is step 2? First, run your short run regression model. As we have discussed above, that short run means we do not run the regression model on the level data, but we have to run the regression model on first difference. So like the delta t, delta yt is the dependent variable, and delta x, change in x, is the independent variable. This is not the enough condition to run here, but we have to add the error correction term, this term, the lag of error correction term, as an independent variable. The lag of error correction term as an independent variable. Here beta shows the short run coefficient, this one, as we have discussed above, and on the other hand gamma. What does gamma show? If gamma is negative and significant, if the value of this gamma would be negative and significant, it means model will adjust towards long run value or long run equilibrium. Now what does it mean? What does this negative sign show? If the gamma would be negative and significant, the model will adjust towards equilibrium. How and how it happens? Now we are going to discuss this. Here the explanation of negative and significant ECT coefficient gamma. So as we have discussed above, in the long run, the all upcoming values and previous values would be same for all the variables. So yt in equilibrium, let's suppose the equilibrium value of y is 10. So in all period, in considered 9 period is 10, same as x is 25. In considered 9 periods, x would be 25. If the all y values are same, so it means error term would be 0 in the long run. In the second table, what we can see here the difference between these two values, difference between y values of y in each period. So all difference would be 0. So all difference would be 0, or the same values of variables would show the long run state or long run equilibrium. Now what we are trying to understand, the negative and significant sign of gamma. Why is it necessary for long run adjustment? So here we are going to suppose that if model shock faces any shock, and the equilibrium value 10, after facing some shock, it would be 5. It would be 5. So if the equilibrium value estimated value is 10, but due to some shock the actual value would be 5, it means this is the actual value 5 and this is 10 is the estimated value, and if we find the difference between actual means 5 and estimated 10, so the difference between these two value would be -5. This is called error. This is the error value. 5 minus 10 means actual minus estimated would be 5. So on the other side, if we are going to find the change in next period, means in period 5, so the equilibrium value is 10 and the actual value of period 4 is 5. So if we are going to find the difference between these two value, means 10 minus 5, what would happen? Error, the difference would not be 0, it would be 5. Zero value of change shows the long run equilibrium, but if the economy or model facing some shock, so the equilibrium value would change to 5 instead of 10, and if the actual value is 5, the error would not be 0, it would be -5. So the difference in next period is 10 minus 5. 10 minus 5 is 5. So this is the case when value has decreased, equilibrium value is decreased. So on the other side, if the value has increased, means 20, the equilibrium value is 20 here, actual value is 20 here, and equilibrium value is 10, it means actual minus estimated, the error would be 10. The error would be 10. And then if we find the difference between period 4 and period 5 for value for y, so 10 minus 20 means minus 10. This is the difference of y. This is the difference of y, not x. So I repeat, if a model faces some shock and the value would be 5, so error would be minus 5 and the difference would be 5. So and at the same, if the value of after facing some shock, the value would be 20, so it means error would be 10 and the change would be minus 10. So what we have discussed before, we have discussed for long run equilibrium, change would be 0. For long run equilibrium, change would be 0. So if we trying to make this value is 0, what should we do? We have to decrease it. We have to decrease. We have to decrease the value 5 to 0. We have to decrease, this is the important one, we have to decrease the value 5 to 0. At the same time, we have to increase this value to 0. At the same time, we have to increase the error value in previous period. We have to increase the error value in previous period. Yes, we have to increase. This is the important thing. So to make change would be 0, we have to decrease the value of change and we have to increase the value of error term. So there is a negative relation between change and the lag error value. The negative relation between change and the lag error value, this shows the same thing. If the gamma is negative and significant, it means model will adjust towards long run value or long run equilibrium. Here for 20, if the new after facing some shock, the value of y would be 20, so the error would be 10 and the difference between 10 and 20 would be minus 10. And now if we want to achieve the equilibrium after this, so it means we have to increase this value towards 0, we have to increase and we have to decrease this value. So in this case, we are also getting the negative relation between change in y. This value would be increased and this value would be decreased. So the negative relation between change in y and a lag error term is negative, and if this value, if this coefficient would be negative and significant, it means model will adjust towards long run value or long run equilibrium. So this is the theoretical explanation. So this is the theoretical explanation of negative sign of gamma. Now we are going to discuss the range of the value of this coefficient, ECT's coefficient. If gamma is between 0 and 1, obviously with negative sign and significance, then adjustment will perform monotonically like this. Means value if less than equilibrium value, it will move towards equilibrium value, and if the value after shock is above the equilibrium value, it will move towards the equilibrium value like this. This would happen when the value of gamma would be between 0 and 1. On the other side, if the value of gamma will be between 1 and 2 but less than 2 obviously, with negative sign and significance, then adjustment towards equilibrium will be in dampening manner like this. So this is the case if the coefficient would be greater than between -1 and -2, and if the coefficient would be less than 1 or between 0 or -1, so adjustment will be done monotonically. In this case, adjustment will be done in dampening manner. So this is the theoretical explanation of error correction model, that how negative and significant sign of gamma would show the long run adjustment in the model. So now we are going to apply this error correction model. As we have discussed that error correction model is a part of Engle Granger 2-step procedure. So we are going to apply the whole procedure. So step 1, run your regression. Here is the model where GDP is the dependent variable and labor force, capital and FDI are independent variables. So open as equation, right click OK. So this is the first step, run your regression. The second step, find residual or error. So go to process, make residual series, right, its name here is ECT, error correction term, then OK. Here you can see the error correction term has appeared here. Now the third part, apply unit root test on residual or error. So for applying unit root test, open this error term, view unit root test, and then OK. So here the significance value is significant. It shows the error correction term is stationary at level. The significance shows the rejection of null hypothesis, and it shows the error correction term is stationary at level. So as assumed, if all variables are I1, as assumed that all variables are I1 here in our model. So if all variables are I1 means stationary at first difference, and error is I0 means stationary at level, it means cointegration or long run relationship exists. Here we can see this shows there is a long run relationship. So if this is the case, means cointegration exists or long run relationship exists, we can move towards the step 2. Step 2. In a step 2, first we have to run short run model with the lag of error correction term as a independent variable. What we have to do, we have to run our model as a short run model. So quick estimate equation. In short run model, what we have seen before, in short run all variables are considered in first difference form with the independent with the lag of error correction term as an independent variable. So the dependent variable is GDP, so we have to write here d GDP. D shows the change constant, d labor force, then d capital, then the FDI, then ECT without D, error correction term, not the current one but the previous one, error correction term, the lag of error correction term ECT -1. So this is our short run model with the inclusion of lag of error correction term as an independent variable. So if we write OK, so this is our model. Here we can see that ECT has negative sign and it is also a significant. It means the long run adjustment would be possible. These coefficient shows the short run coefficient because all variables are in difference form. These coefficient shows the short run form, and the coefficient of ECT term is negative and the probability shows it's significant. It means the long run adjustment would be possible. Here coefficient of ECT is 0.2734, which shows the speed of adjustment towards equilibrium. Here the speed is 27.34% per unit time. Per unit time means here we are using the annual data, so per unit time means 27.34% adjustment will be done in a year. If we use the monthly data, this adjustment would be done in a month. So here ECT, the value of ECT shows the adjustment, and 27.34% adjustment of the shock in a unit per unit time here in a year. And that is why this value shows the adjustment towards equilibrium. So that is why this is called error correction term. Error correction term. Error means the shock we have faced, or a model has faced the shock. So the error correction term shows the speed of adjustment towards equilibrium. Now if the short run model or error correction model shows insignificant results, then we can follow Henry's 1980 approach of general to specific model by using different lags of dependent or independent and dependent and independent variables. Like for this model, what we have to do, if we want to increase or check our model with different lags, so we have to use the lag of dependent variable, lag 1 here, and we can use the lag of all variable, but here we are using just for 2 variables. Like this. So this is the model. This would be the speed of adjustment now, but it is also a negative and significant. So this through this way we can increase the fitness of our model or significance of our model in short run or in long run adjustment. So if this video helps you to understand the error correction model, so like and share the video and subscribe my channel TJ Academy.